Questions? Is this helpful so far? All right, let's do nutritional ergogenics is the last one. This was primarily carbohydrate loading, was what we talked about. What's the primary fuel of the body during exercise? It's carbohydrates, or glucose, or glycogen. Can you store a unlimited amount of carbohydrates as glucose or glycogen in your body? No, there's a limited amount you can store. Where's the two places you store glycogen primarily in your body? Skeletal muscle and liver are the two primary places. Okay. Let's see. What's an advantage of carbohydrate loading? Okay, what type of event would you want a carbohydrate load for? A long endurance event. Okay, so let's say you were doing an event that is an endurance event that took 45 minutes. Would carbohydrate loading be beneficial for that event? Probably not. Okay, it probably needs to be about roughly 90 minutes or longer before you're going to see an advantage with carbohydrate loading. So we're talking about long-term aerobic type activities are going to benefit from carbohydrate load. If you were going to carbohydrate load, how would you do it? About how many days prior to the event would you need to make sure you ingested a large number of carbohydrates? Okay, with the new method of carbohydrate loading, it's about 3 to 5 days, okay, before your event. And the key is to make sure you get a high volume of carbohydrates and a large percentage of your overall calories as carbohydrates. Do you remember what the recommendation was for how many grams per kilogram of body weight? About 10 grams per kilogram of body weight is the recommended amount to eat, and that's quite a bit. You really got to force yourself to do it. Yes?
The new method of carbohydrate loading?
Yeah.
Should you don't have to abstain from having carbohydrates. You just eat normally.
You can just eat a normal regular diet, but then about 3 to 5 days prior to the event, you need to switch over to about a 90% of your calories from carbohydrates, as much as you can, and you just got to eat a ton of it. You almost have to force yourself to really pack them in. That's the only way you can essentially trick the body into storing more through that method, is to eat a high volume. Okay, what about, we said an event that took, say, like 15 minutes or 30 minutes. You don't have to necessarily carbohydrate load. It's not going to be advantageous for performance. But what would be good for those athletes who train for those type of events? To eat carbohydrates in a large amount on a regular basis. Remember the graph I showed you with the high carbohydrate diet and the low carbohydrate diet? And they did 2 hours of exercise each day, and the low carbohydrate diet, they're kept going down and down and down. So it's really important to eat a high carbohydrate diet on a regular basis if you're an endurance trained athlete. What's special about ingesting carbohydrates after a workout? What's special about ingesting carbohydrates after a workout? You can store more muscle glycogen within a window that starts about 30 minutes after exercise. So within that 30-minute after exercise window, you will store more muscle glycogen if you can ingest carbohydrates during that time period. After that, the amount at which you'll store goes down and down and down. So you hit about 2 hours. And then it's the same as just normal resting periods of time. Okay, so what's probably the best technique to try to get carbohydrates in during that half hour? To try to drink it. That's the big deal. Now, what about what's also special that can help you store more muscle glycogen post-workout about the beverage itself? If it has a protein to carbohydrate ratio or carbohydrate to protein ratio of about 4 to 1. Okay, if it has a little bit of protein in it, it turns out you'll actually store a little bit more muscle glycogen. And what's the whole idea with chocolate milk? Chocolate milk is about a 4 to 1 carbohydrate to protein ratio drink. That's what is special. But you don't have to do chocolate milk. There's lots of beverages that are 4 to 1. And even if you don't have a 4 to 1 beverage, just drinking, say, Gatorade or a soda or fruit juice is still going to be as effective. We talked a little bit about caffeine. Caffeine can help explosive type sports by increasing neural drive to the muscle, which can make them perform better, be more explosive. But it can also help endurance exercise by doing what? Caffeine causes fatty acids to be released into the bloodstream. And if you can release fatty acids into the bloodstream, it's thought you'll use it as a fuel instead of using what? Glycogen or carbohydrates. So it'll make your carbohydrate pool, your glycogen pool last longer. So that can be positive. What's the problem with that? What's the problem with using caffeine in this way?
Caffeine's a diuretic.
Well, it's a diuretic, but will it be effective in switching your metabolism from carbohydrates over to fat?
No.
Not necessarily, especially if you've been doing what?
Carbohydrates.
If you've been carbohydrate loading, the body's going to preferentially use what it's eaten the most of recently. So if you've been carbohydrate loading, even if you use caffeine, you'll stay using carbohydrates as your primary fuel. So who would it be effective for? People who are doing endurance exercise that are relatively untrained or haven't been carbohydrate loading. It can be effective. Okay, that's a pretty good summary of some stuff. Questions? Yes?
I just have it written down like foot strike hemolysis, but I didn't really understand what the point of that was.
We were talking at the very end of the nutritional ergogenics. I just had a very short statement about vitamins. And for most people, if they eat a normal, healthy, balanced diet, vitamins are not going to be effective in improving performance because they've already got normal stores of vitamins and minerals. The one big exception appears to be iron stores, particularly in women and endurance-trained athletes. And why endurance-trained athletes oftentimes have lower than normal iron stores, particularly in runners, is because when you run, you have very small blood vessels in the bottom of your feet. When your foot hits the ground, you essentially crush the blood vessel, and it breaks apart the red blood cell, and then the iron that's in the hemoglobin can't be just floating around free in the blood, so it gets scavenged up by the liver, and sometimes it can be excreted that way or not recycled. So that becomes an issue. Okay. Any other questions? Okay, I got sample questions online with answers. Again, if you have any questions, email over the weekend, and then I'll be in the SRC lobby early. Okay. Was this okay? All right.